My name is Ray Ryan, and
I'm Zach Klippenstein.
And we are here to talk to you about Square Workflow. Actually, we're here again to talk to you about Square Workflow. This is 2 years running now that we've been giving some variation of this talk. 2 years ago I came, the ambient is amazing. 2 years ago I came to tell you about the problems our iOS and Android teams were having with scaling our apps across hundreds of screens that are kind of collapsing under their own weight, and about a pattern that we thought we had discovered called that we called reactive workflows. Last year, a couple of us came out to give you an update on how that was going. We showed some of the code and techniques we'd been using on an internal library, but we weren't quite confident enough in it yet to share it with you, and so we hadn't open sourced it yet. And it turns out that that was a good decision, because the warts on it were because we didn't know that we were accidentally reinventing React. We noticed that, we figured it out, and so we gave ourselves the permission to write one more variant on React, but this time intentionally. And now we're happy with what we've got. We have an open source library. It's up on GitHub. We'll put up links and stuff at the end. It is written in both Kotlin and Swift. Our Android and iOS teams are using the same APIs to the extent the languages permit. They're using the same documentation with little Swift and Kotlin snippets inside of it. We're using it on both platforms like crazy in production, and we're on the verge of slapping an alpha label onto it. The API is stabilized enough that we're pretty confident. So let's talk about what it actually looks like, how it actually works. Our main interface is called Workflow. If you're coming from a React Redux background, substitute the word component every time you see the word workflow. We're a Dagger shop, so if we were to overload component, it would have been bad. And we've got three parameterized types on Workflow. It has input in the form of a props T, props for properties. It's a kind of intentionally vague term. It means whatever is useful for your workflow to actually get itself going and do its work. It has a rendering type that gets emitted to give the outside world a view of what the state of this of the workflow and how it can be advanced. 9 times out of 10, this is going to be a view model of some kind. Not a Jetpack view model, but a lowercase v, lowercase m view model. A struct with enough strings and stuff to give you tell you what to put on the screen, and little functions hanging off of it with to be fired as event callbacks. Whoops, I skipped a bit. And then finally, there's an output type. Wow. There's an output type that you can report back to the caller of the workflow what it's actually accomplished and what information it turned up for you. So diagrammatically, we can look at it like this, with the props coming in from the caller, the output going out to the caller, and while we're running, a little rendering happening on the side there. One thing you'll notice that we don't have in the param types is a strict event T definition. Events are an important part of what goes on with the workflow, but there's flexibility in what sorts of types, what kind of formalization you work with there. They're all kind of, UI events will come in routed through the rendering, but there's other sources of state change that we'll get into as we go on. So while we were preparing this talk, we were encouraged to think of a scenario that would kind of keep it relevant for people, like maybe we could put together, pretend to write a conference app. It might have a conference session editing workflow where a session ID goes in, and then the rendering type is the editing screen with on-save and on-cancel callbacks. And then once it's done, it can report whether it's saved or canceled. But we kept falling asleep while we were writing that, and so we decided that we were going to build the talk around a game workflow instead. And for repeat viewers, I promise that the game is not tic-tac-toe. So let's look into the, wow, we're getting double spacebar action here. Zach, you need a new laptop. What I've talked to you about so far is how the overall modeling works, but I haven't given you any Android bits yet. We've got little structs coming out, and then the obvious question is, how do those structs turn into things that actually get on the screen? Workflow is divided into kind of two main core modules. The heart of it, Workflow Core, is strictly Kotlin, no Android dependencies, platform neutral, and it's all about this modeling bits. Paired with that is the Workflow UI library. That is Android specific. It's got kind of three main moving parts, although you don't have to think about them too much in the day-to-day coding. They're the Workflow Runner, whose job is to actually kick off your workflow tree, listen for the outputs, monitor the rendering stream. the view registry, which is responsible for pairing particular types of renderings with particular layout XML files or particular functions to create view factory functions, that kind of a thing. And then a workflow layout, which is the glue that serves as your activity or your fragments content view, able to actually display all of this stuff for you. So once you turn the key, the way this all looks as it's running is something like the game workflow is given the game props information that it needs to actually start running things. It kicks out a rendering. Workflow runner, workflow layout, view registry have a conversation, and they agree that the game layout, .xml, is what should be inflated now. And eventually the user will emit an event. The workflow will decide, hey, you know what I need to do is update the rendering. We don't inflate a new layout. It'd be silly to redo that work. We just update the existing one. Another event happens. You win the game eventually. You actually can't lose this game. And the game over output happens. And that's it. That's kind of like the kernel of our runtime. So those are nice concepts, but what does the code look like? For that, I will turn it over to Zach, who gets to do all the fun parts.
All right. Before we get into code, I'm just going to talk real quick about some more concepts real quick. So we talked about the workflow interface, but typically you don't implement workflow directly. We provide a stateful workflow abstract class. So if you've used Flutter and you've seen like stateful widget, stateless widget, this would probably look familiar to you. Stateful workflow gives you a couple of abstract methods you implement, and we'll look at that in a second. So workflow has 3 types that we saw earlier. Stateful workflow adds a 4th type, state, which is internal to that particular implementation of a workflow. So this will probably make more sense once we actually see some code. Before we do that, we put up a template repo on GitHub, so you can easily just click this, use this template button, get a fresh Android app that you can start hacking on and build. So what that gives you is 4 files that are really interesting, and we'll just kind of dig through these. So the app that you get is a really simple app. It's a single screen, it's a single workflow. The screen either shows hello or goodbye, and when you tap it, it switches between the 2. So the workflow has no input or no props, so we use unit for that type. It has no output, so we use nothing. Those types are different because outputs are events, effectively. So by using nothing, the compiler can enforce that you can't emit an output. So we get a little extra type safety. And then we have a screen called hello rendering that we spit out, and it has a single event handler on click. So let's look at hello workflow. So this is an object that subclasses stateful workflow. It has, as we said, no input, so we use unit for that. We use nothing for the output type, and we define our own state and our own rendering. So let's look at what those look like. So state is just an enum. State can be whatever type you want. It's usually a sealed class, as you've probably heard in other talks this week. But we'll keep it simple for now. It's just an enum with 2 values. We can toggle between them. And we implement the first method on stateful workflow, initial state, to determine what our starting state is when we start the app. So we'll start in hello, and you'll also see that there's the props and a snapshot thing that we get passed in. We ignore the props, and snapshot is there to support persistence across process death. So we have full support for that, but we won't talk about that today because there's a lot of details there. So the rendering type, also pretty simple. We just have a string message and function to handle on-click events. It's probably pretty familiar if you've seen any of the other talks on architecture this week. To actually implement the click handler, we use what we call a workflow action, which is similar to like a Redux action or reducer. And actions can do 3 things. They can change state, so they get the state passed in through a receiver property. They can reassign that to update the state. They can emit outputs by returning the output value. If they return null, there's no output. So a lot of actions return null. And they can do some side effects like logging and stuff. So if you want to log button clicks to your analytics platform, you'll probably do it in your workflow action. The second method that we implement on stateful workflow is called render. This also gets the props and it gets the state as well. So we can use those to implement our state machine. The third thing it gets is a render context. So this is basically how we access the runtime. We can do a lot of stuff with this. We can run child workflows. We can do asynchronous work, and we can implement event handlers. So the way we do event handlers is, so let's actually first look at this rendering that we're creating to return here. This is just the definition of our screen. So we pull the name out of the state, and then we create a Lambda to implement the onClick handler. In that Lambda, we send the hello action we defined to a sync. And a sync is a strongly typed, basically dispatcher that we can create in the render method. So here we're just using workflow action directly, but you can, if you have a lot of actions, you can make syncs that are specific to different actions to add some type safety. So that's the entire workflow, pretty much. So now let's look at the layout runner. So we've got this rendering screen. We need some way to actually get that on display. So layout runner is a interface that is basically a really simple presenter. It's strongly typed to the screen that it displays, in this case, the hello workflow rendering, and it typically gets an inflated view in its constructor. Because we get in the constructor, we can do all of our find view by ID calls right away, and then we implement show rendering. This is the only method on this interface, and it gets called the first time that this screen is emitted by the workflow and the view is inflated, and then anytime the workflow emits a new version of this screen. So this is where we do all of our actual view binding logic. We just assign the message to a text view, real simple, and then we add a onClick listener that forwards it to the rendering. So how do we get that root view? Every layout runner is associated with a view binding. A view binding is basically a map of the screen type to basically a view factory. We have a couple of variations of this. The most common one is just bind, which takes in a layout resource ID and the constructor for the layout runner. Anytime a workflow emits that screen, we'll look it up in this, we'll find the view binding, we'll inflate the view, and then bind the layout runner to it. We only inflate the view the first time we show it, and then we just update it after that. So you're not inflating views every time. So that's the layout runner. But how does this actually all get wired up? We need an activity, because this is an Android app. So this is our activity. This is all the code there is. We're not deleting stuff. It's very simple. So first of all, we take the layout runner that we defined before. If you were watching really closely, you'll notice that we implemented the view binding with a companion object on the layout runner. So we can just refer to hello layout runner directly, and we get the view binding. We add that to this view registry. A view registry is basically just the total map of all of your view bindings. You can merge view registries like you can merge maps. So you can, it works really well with modular apps if you have a lot of modules. If a module has a set of screens, it can vend a view registry for all those screens, and then your app module can take all of your view registries and combine them, and now you've got a view registry for your entire app. So our activity just implements whatever activity you want, really. There's no special workflow activity type. We override on create, and we call, instead of set content view, set content workflow. This takes a Lambda that returns a config, and the reason it takes a Lambda is because we call this on every activity creation, but we only need to actually set up the workflow the first time, because we use a Jetpack view model behind the scenes to maintain state. And the config just associates the actual root workflow with the view registry. This set content workflow method, this is the simplest version of it. You can do more things. If you want to support persistence across process death, you can override onSave instance state, forward that to the workflow runner that set content workflow returns. If you want to handle an output from the workflow, you can pass another Lambda to handle that output and, for example, finish your activity. We have sample code for this in that template repo that I showed earlier. So this is great for a simple workflow, but we're writing real apps. How does this actually scale, right?
I'm so glad you asked. So we have our little conversational stick established. So we've shown you how to write a simple one-screen app. It's not very interesting. Most of your apps probably have a lot more than that. We set out on this journey because we ship an app with literally hundreds, approaching 1,000 screens, and keeping that managed is sort of the entire point of this exercise. So We talked about the simple workflow module, and we talked a lot about the props in and the output out. The question is, obviously, where are they coming in and going out to? And the answer is always the parent workflow. Workflows are in a tree, and there's a root workflow who will get its props and report its output to that workflow runner in the activity or fragment. But then after that, it's turtles, its workflows all the way down. So let's imagine, for example, we have a simple two-screen app. It's got a home screen and it's got an away screen. When it's in the I'm skipping slides again. So one thing to notice is the rendering type of this main workflow, this composite workflow, has changed. Instead of being strictly typed to main screen or something like that, it's of type any. It doesn't know exactly what screens its children are going to choose to render. It's able to pass any type of screen out. Now we start the thing running, we enter the home state, and we kick off the home workflow. The home workflow renders the home screen. The parent workflow that's delegating to it passes that off as its own. Home output happens. The main workflow reacts to that, advances its state machine, kicks off the away workflow. An away screen comes out, is displayed, away output is rendered, we go back to the home state, and so on. So that's kind of the simplest case of our composition model. But you can do more interesting things. Like imagine that we want to take our home workflow and we want to give it a master detail treatment. The first step for something like that is we check its rendering type, we throw away the bespoke home screen rendering, and instead we use the generic split screen of any, which, like it sounds, is basically a tuple of renderings. It's got a first one and a second one that the view can choose to do with what they want. Implied here, something that we're not going to drill into in details for lack of time, is that the view registry stuff that we showed you is also a recursive mechanism. When your layout runner is given the view in its constructor, it also has the option of asking for the view registry itself as a constructor argument so that a rendering of renderings can be turned into a view of views and so forth all the way down. You might think that this implies that we actually have a splitscreen.kt class in the library, and we will soon, very soon. We have other ones that handle harder cases. Split screen will be in there before we alpha. Anyway, the home screen, home workflow will build split screens, and it could do something like kick off two children at once for its master detail treatment. So it'll have the master workflow kicking out master render, and at the same time it'll be running a details workflow that kicks out details render. The render call is a synchronous one. There's no asynchronous stuff happening here. And the calls to kick off a child workflow and get its rendering is also synchronous, so this can all happen on demand and possibly repeatedly. You keep these things idempotent. The home workflow stitches those together into its split screen, kicks those back up to the caller calling parent workflow, and again, everything is just happening by delegation to children. Just to complete the sketch here, let's look at the communications. Suppose we make a selection on that master workflow. I click from the list or something. The master workflow's output would be something like a selection object that gets updated. Home workflow, all it does is pass that output down into the already running detail workflow by updating its props. The detail workflow sees that as another source of state change, re-renders itself, everybody else re-renders, and now the details for the next selection are showing. The master workflow is highlight has been updated to reflect what was selected, and so on. Okay, so the final piece of the puzzle here is what happens when I need to talk to the outside world. It's all very well and good to be managing trees of modeling your app, but there are file systems, there are cloud services, and how do we interact with those? Also, I'd like to apologize again to people who have attended the last 2 years where I always blew off this question and never showed how we handle it. We will show the code this time. So the way this works is, in addition to being able to run child workflows, a workflow can also kick off a reduced thing called a worker, where a worker is pretty much just like a workflow, except it has no props, it has no rendering. It basically all it can do is produce a stream of outputs. Pretty much a worker is an RX observable or a Kotlin coroutines flow. We've said the word coroutines, so our session description is now truthful. It's basically an RX observable or a flow with an extra comparator function attached to it. This is a stream of events. So something that's really easy to make from a retrofit service call or from a Rooms or SQLite database. It's all very bindable. And with those moving parts, the workflows of workflows and workflows able to kick off workers, that really is a complete picture of our runtime. That is how these things work. So with that, I'm going to hand it back to Zach so we can continue our journey through the code and maybe actually make a game go this time.
Wow, master detail, that's fancy. Let's keep it simple for now and just write a really simple game. we'll just have 3 screens. We'll have a loading screen so we can load some map from the network. We'll have the screen where we're actually playing the game. And when you win, we'll show a little dialogue that lets you go back and load the next game. And you can't lose this game, so it's just like real life. So we need a root workflow. Every app needs a root workflow. We'll just call it app workflow. And it'll render anything like we saw before. And so workflow started as a way to kind of define composable state machines primarily. And so whenever you're writing a workflow, you always start by thinking about what states it needs to have. So here we'll have 3 states, 1 for each screen, loading, playing, and finished. So let's look at how those actually look in code. You'll see that we have an object that implements app workflow. Looks familiar from before. It implements stateful workflow. It has no input. It has no output. We define our own state type. The state here is a sealed class with 3 subclasses. Loading doesn't have any data, and then the playing and game over states both take in this game props. So what is game props? Well, we need to load something. So the loaded game we're going to call game props. And it's pretty simple. It's just the rectangular board size, the position of the spawn point, and the position of the goal. And that's all we need to know to start playing the game. So in the loading state, we have to kick off some asynchronous work to actually load this. We're going to use a worker like Ray just talked about. And this worker is going to eventually emit game props. While we're doing that, we need to show a loading spinner or something. So we're going to render a loading screen. So let's talk about this worker. We're going to implement, or we're going to write basically just a retrofit service. It's going to return a flow of game props. This could be a suspend function or a single, whatever you're using. Basically, any asynchronous API can be turned into a worker. So we're going to inject that game loader into our app workflow, which is now a class. And here we're pretending to use Dagger, but you can use Coin or whatever else you want to use. So we just inject that, and then we call load game and turn that into a worker and store that in a property. Normally, you don't want properties in your workflows because your state should all live in your separate state type. But dependencies like this aren't really state; they're just dependencies. So it's really common to inject a lot of services and stuff like that, so that you can refer to them later. So once we actually load the game, we need a workflow action to start playing the game, and it's pretty simple. We just set the state to playing. We store the game props that we just loaded in there, and we don't emit any output. To render this state, we just ask the context to run the worker, and we pass a lambda that gets run when the worker emits something. So this is kind of looks like a subscribe call, but you don't actually have to manage any subscriptions. So you can't leak any disposables or anything like that. When the game loader emits the game props, we run the start game action. And while we were waiting for that, we rendered the loading screen. So this loading screen, it's analogous to the hello workflow rendering we saw before, but the implementation is much simpler. Since there's no actual data to render on the screen, we can just call this bind no runner method, and all we need is the actual screen type and the XML layout. We don't need to have a layout runner anywhere. So it's a lot simpler. So that's the entire loading game state. So the next state is playing. And when we're playing the game, we're going to actually delegate all of the game logic to a separate workflow. This is great because it keeps the actual kind of overall app state much simpler, the app workflow, and the game workflow can evolve kind of on its own and get more complex as we add features. So we won't talk about the game workflow itself because that can get really fancy, but we do need to know what the props type the game workflow requires is, what outputs it has, and what it renders. So we know that we're going to pass a game props. It's going to emit when the game finishes, and it's going to render some game screen that we're just going to forward from the app workflow. In code, we started with this loading game in render, so we're going to add a case for playing game, and all we're going to do is render the game workflow by calling render child, pass it the game props that we've stored in the state, and a lambda to handle outputs from the child workflow. When the child finishes, we're going to just call some finish game action, which we'll talk about in a second. So this game workflow, the actual types we just define a type alias. Presumably, the actual game implementation lives in a different module somewhere. But we have the entire contract for the game workflow is defined right here. It's really simple. We have something that we emit when the game finishes, and then this game screen thing, which looks a lot like the game props, but it also has an event handler. So that's the game workflow. When the game actually finishes, we need to run this finish game action. All that does is set the state to game over. We copy in the game props, and we don't emit any outputs. So why are we storing the game props in the game over state as well? We're already finished playing the game. We shouldn't need it anymore. Well, if we look back at our wireframes, you'll see that the game finish screen actually is just a dialog that shows over the game screen. So we need to render the game underneath the dialog, which means we need the game props to render the game. You could approach this by like snapshotting the last game screen and then showing that, but this is much simpler to reason about because you don't have to like special case the two things. You just know as long as the game screen is showing for whatever reason, I just need to render the game workflow. So diagrammatically, we're going to pass the game props down just like before, and there's no output because the game's already finished, so we just ignore that, and we spit out this game screen, but we also need to spit out the game finish screen. The way we do both of those is by using an alert container screen. This is a special screen type that is provided by the library, and it basically just combines a body screen and a dialog. When you start rendering one of these screens, the library will automatically pop up a dialog, and when you stop rendering it, it'll tear the dialog down. You don't have to do any manual dialog management, but we're using an actual Android dialog under the hood. So the render method for the game over state, first thing we do is we render the game again. This looks very similar to the playing game state, but we don't actually do anything if an output is emitted, so we just use no action, which is a pre-built workflow action that just does nothing. To get the game over dialog, we create an alert screen, which is again a type that we provide that just describes how to build an alert dialog. We can set some buttons, the text, the message, we can set the title too, we don't do it here, and then we need an event handler for when one of the buttons is clicked. We make a sync, and we send our restart game action to the sync when you click one of the dialog buttons. We don't show what the restart game action looks like, but you can probably imagine from the other actions we've showed, it just sets the state to loading again. To combine those, we wrap them up in an alert container screen and return that. So that's pretty much it. The actual code for the actual game is in the. There's kind of actually two versions. We have a repo just for this project, a separate repo on GitHub that we'll link at the end of the talk. And so you can look at the actual code for this, and then we have a more complex game in the actual workflow repo as a sample that has like monsters and stuff that can eat you. And I would really encourage you to go look at that because it's kind of cool. Every AI and every like character is its own workflow, and so it kind of demonstrates some interesting ways you can actually play with this compositional model. So let's see what this actually looks like. So there's the loading screen. Here's our simple game. We will try to find, and there we go. And you win. You restart, and you go back to loading. And that's like pretty much all the code. We can do all kinds of cool things, though, when you have an entire app that's modeled as a set of discrete states, and you've like really defined all this stuff really well. So one of those things you can do is time machine debugging and stuff like that. So let's move it around a little bit. We shake the device, we enter time machine mode, you can scrub around history, and if you scrub back to present time, we go back to the real app and you can control it again. So that's basically our game. For the more complex version, again, look at the GitHub repo, and I'll give it back to Ray to wrap up.
So, to recap, here's Square Workflow. It's available today as a CocoaPod and Maven Central. We are using it in production, and we're going to continue doing so, and we've been pretty happy with it. We've noticed that developers on both Android and iOS have started kind of adopting it and teaching each other about it without telling us about it in advance, which is a good feeling. With that, we're done. We can take questions at the microphones here. We've also been We can take questions online if anybody has been playing with the link up at the top there. If you don't have questions for us immediately, we actually have a few canned. So are you actually using this stuff? Well, yes, we are. Like I said, it's a huge portion of our flagship app, point of sale on Android. It's a growing portion of the corresponding app on iOS. There's at least one entire app written on it in iOS, and we are very committed to this. There's an asterisk on the answer there, though all of the code in the library is being used in production except for the Android View registry. We have something else, an earlier version of that we're actually shipping, but the Swift analog to the Kotlin View registry is in heavy use. The concepts are the same. The code is nearly identical, and like that. We have a question from the moderator. Do we have plans to roll it into a MPP product? I don't know, because I don't know what MPP means.
Yeah, so we have taken care to write most of the code in a multi-platform friendly way, and it's not a multi-platform project right now. We are still relying on JVM only OKIO for one little detail, but that's getting very close. I think they a couple of weeks ago, I think, started publishing multi-platform artifacts for that. So we just have to actually do the work. But yeah, there's no reason this can't support multi-platform. We're using a lot of coroutines under the hood, as Ray said, and that's the only real dependency that this library has is the coroutines library. So yeah, eventually.
I bound that M to model, and it was like just all downhill from there. Another interesting fact, way to look at this for the MPP lens, it may or may not ever be interesting to try to get Android and iOS developers sharing the actual code. But lots of people this week have been talking about how getting similar tools in front of the developers is maybe all that you really need to do. Netflix guy was just talking about multi-platform by shared architecture. There are costs to code sharing. But you can get a lot of the way there by having mindset sharing. Our Android developers and our iOS developers can have useful conversations with each other already, whether or not we get to MPP. That said, how could we resist? And once something like that is in hand, this could be interesting to use in a JavaScript app. We have a lot of non-UI-based workflows going on inside the Android app already, and you can imagine making use of this kind of thing on servers. It's just a nice general kind of composable state machine model, whether or not UI is the target.
Yeah, we didn't talk about it too much here, but the APIs in Swift and Kotlin are almost line for line identical, and we put a lot of work in and continue to make a lot of effort to keep them that way, which is surprisingly hard, actually, because teams work on different things, people have different ideas, but it really makes it easy. Like Ray said, we have people helping out iOS people who are giving Android developers tips on how to architect things, and you can talk about this cross-platform. It really solves a lot of organizational problems, and you can write design docs kind of once, and you still get all of the native tooling that you would expect on whichever platform you're working on. So you kind of get the best of both worlds. Ray and I have to do a little bit more work, but that's what we get paid for, so it's fine.
And we only have to write the docs once. So another question canned we have for you is that all there is? No, we've shown you kind of the basics to get a taste of it, but we do provide a lot of stock containers, including a backstack container, a general modal container, not just something for alert dialogues, but the ability to do modals based on any kind of a custom layout. There is a workflow fragment that seems like a kind of a nice way to try to start stitching this stuff into a legacy app. Our own app is not workflows all the way down, although that is the goal. It does work nicely as a black box inside of existing traditional apps. You saw the snapshot thing floating around there. That's our hook into Android's the activity bundle, the persistence mechanism for surviving process death, which is important to us. We have very tidy RX2 integration, very tidy Kotlin coroutines integration, and our testing story is very sweet. Unit tests of individual workflows or entire stacks of workflows cover a lot of ground and run super fast. And then maybe the most burning question on this week of everybody describing their flavor of React and Redux and how you should use it is why should you use workflow? If you work at Square, you really need to use workflow. If you work anywhere else, I don't know, there's a lot of choices. Pick one and have fun with it. We think that we've got a particularly strong take on scaling up navigation, which was the main use case that drove us here in the first place. It's easy, Redux and all worked really well across a handful of dozens of screens or whatever, but once your navigation decisions become choosing where to go next across hundreds of the things, that's the code itself that becomes complex. And we found that this is a way that we can gather that into super workflows and test it all in one place.
Yeah, so a lot of talks this week are about like Redux-style architectures, and that was a huge inspiration for this, Elm in particular. And one of the things that we tried to do as well is kind of make the state itself composable. So instead of having one giant store, which you can kind of view the runtime as having it store internally, but the actual states break down really well, and you can decide what state should be internal to a workflow, and only that workflow knows about it. It can decide what parts of that state to publish through its rendering, and what parts of that state to get from its parent through its props. So it's really easy to take like a giant app with like tons of state all over the place and like compose that really well, and it's still easy to reason about.
So we have the, go ahead.
Yeah, I was just going to lead into that. So like we don't, so one of the things we try to solve with this is navigation. And so we don't use fragments. There is a question for the audience about what about fragments, shared elements, transition, and backstack. So we don't use fragments in our main app. We moved to a single activity app a while back. And we, I don't know if we've given a talk on it, but we use a library that we wrote internally called Flow. And was basically just
ages ago.
Yeah, backstack management using views. So we use that extensively in our main app, and it worked great. Except that when you have complex flows with many screens, and then you want to reuse those parts of those flows in other places in the app, it gets really hard to kind of like slice up your navigation and recompose your navigation at a really high level.
Yeah,
so
basically, you can get pretty far with a single universal backstack. And Flow, the library that Zach mentioned, was kind of the same thing as the navigation manager that's recently come out as like storyboards. A single shared stack only gets you so far. There's a reason that we don't write code in Forth. So for a workflow-based world, on back is just another event like on button click or on text change. It's all implicit in whatever workflow is running at the moment. We've got hooks in the activity integration that will let you capture the on back button pressed, whatever that method is called, and feed that into the system. We're eager for the Android X new shared backstack handling to gel, so we can start to turn to that instead of some hand-rolled stuff that we have. But basically the short answer is backstack what backstack. Also, there was a question about fragments. We still prefer to avoid fragments. Like I said, we do have a workflow fragment that uses a fragment as a vector to let you stitch the stuff into an existing legacy app, but other than that, we're not big fans.
So the nice thing about the way that this library does backstack, we do provide a simple backstack model for you, but it's just something that any workflow can use. So if you have a flow like you're creating something, some sort of account creation or something like that, and you've got a bunch of screens and that are linear, and you want to move forward and back within them, you can write a workflow that does that, and you have full control over the backstack. Then if you want to use that inside of another workflow that maybe only has two states, logged in and logged out, you don't need a backstack for that. You don't need one. You can just implement your state management however you want, your state transitions, and if one of your child workflows happens to have a backstack that it wants to use, that's fine, and it just works.
Yep. So another canned question we have is how is this different from the stuff that everybody else is talking about this week? We differ from React and Redux principally in that they're similar in that, like I said, workflow and component are more or less the same thing. We have a big emphasis on being able to scale the construction of state. Each workflow has a private state. It has an immutable state. There's no global store of state that people are subscribing to bits of. Also, we don't have a global event dispatch system. There's no stream of events that everybody's dipping into and dipping out of. We are skeptical of that from event bus days, whether we should or should not be. Instead, each workflow gets to create its own event sync and whatever as necessary. So events get targeted directly to their owners. We differ from Mavericks in that we are trying to be a global answer. We cared a lot about having opinions on how composition and navigation should happen rather than trying to be incredibly elegant glue for the Android bits. And we differ from Compose in that we're shipping. you can use this now, and we are using it now. When compose actually settles down, it's a really interesting question. Sometimes we think that compose will just replace view registry, and it's very complementary. Sometimes we think that compose will replace the entire thing, in which case, yay, we got ourselves into the proper shape, and then we'll just jump over to compose when that's the appropriate time.
We have 15 seconds left for one more question. How do you recover from activity recreations? So we actually use capital V, capital M view model behind the scenes to actually store the actual runtime. So that handles all that. And if you have a similar activity, that's the only lifecycle you need to know about. When you come back up, the runtime just sets everything back up for you, and that's about it. So I'm Zach. This is Ray. There's our Twitter. We're on Kotlin Slack. We have a Square Libraries channel, and we've got a couple of repos that you can look at to actually play with the code. So thanks.
Thank you.